Hello and welcome. This is going to be our lecture video for April 15th. This will be our final day of Statistics Bootcamp. We're going to look at scatterplots today. So what is a scatterplot? Well, a scatterplot is a way to relate two different variables in a two-dimensional space. So as you're gathering data about individuals, you might take two pieces of data from one individual, like their height and their weight. And now you want to represent both of those at the same time. And so we use our two-dimensional plane to do that. So the x value of this data point gives you, one piece of data about an individual, and then the y value gives you another piece of data. So, for example, this individual right here, we would just go straight down to figure out how much they weighed, and we would just go straight over to figure out what their height is. All right, when we do this, we can start to see trends. One thing I'll say is I found this image here just on the web. I think it's got a slight mistake. I would swap these two titles because normally we put independent variables on the x-axis and dependent variables on the y-axis. And I would say it is more likely that weight depends on height than height depends on weight. That the taller you are causes you to weigh more versus weighing more causing you to be taller. So, but it's not super important. I would just say always put the independent variable along the x-axis when you've got the opportunity. All right. So when you plot a bunch of data points connecting two variables, a trend might emerge. We call this trend correlation. It's when the data points start to form a line. So here we can see in graph number 1 that all of these data points lie pretty closely to a straight line that I can draw right through the middle of them. This is called a line of best fit. Let's go ahead, add that vocab word. Line of best fit. And it is the job of the line of the best fit to get as close to every data point as possible. We want to minimize all of these little distances. If I had to take the distance from each data point to the line, I want that to be a minimum. All right. If you can pass a line through your data, you can say that we have positive correlation when the slope of that line is positive. So here we can see the slope is positive. All right, if the line that gets as close as possible to all of the data points has a negative slope, we can say it is correlated, but with negative correlation. All right, we got a negative slope. All right, and our last one here, if we try and pass a line through this, we're not sure which way to make it go. Should it have a slope that's positive, a slope that's negative? Since we're unsure, we're going to say this has no correlation. All right, in addition to being either positive or negative, correlation can be either strong or weak. And that just depends on how closely do the dots make a line. So if we look at example 1 here, this is a pretty well-formed line out of these dots. Well, these dots, they have a positive trend, but they're much more all over the place. Here we see that again with the negative. We can have almost a well-formed line versus not a so well-formed line. And how we measure this is with all of the little distances from the data points to the line. We can see with moderate, negative correlation, these distances start getting pretty big. So let's list down all the different types of correlation we can have. We can have strong positive, weak positive, strong negative. You can skip moderate negative and just go straight to weak negative, and then none. So I guess there's 5. Strong positive, weak positive, strong negative, weak negative, and none. Okay, so here I've got some data. I went out into the world, approached some individuals and got 2 pieces of data about them. We don't have any labels here, so we're not entirely sure what these represent. We can maybe make something up. But what matters is that the numbers that are across from one another. So it matters that this 2,000 is across from the 7,000. All right, let's practice how we plot these points. So first off, you take the entire row and you write it as an ordered pair. So this is 2,000 comma 7,000. All right, you then put your pencil at the origin and then you move left or right that first number. So the first number is a 2,000, so I move over to the 2,000, and then we move up or down the second number. So you got to walk before you jump is one way to remember this. And that data point represents that top line. We can cross it off. All right, 2,000 comma 8,000. Well, I already know that this is at 2,000, 7,000, so I just go 2,000 a little bit higher up to get to 8,000. 5,000, 5,000. Another data point at that same spot, so maybe I'll use a different color and put it right next to it so I can see they've got 2 data points at the same spot. 6,000 comma 4,000. Looks like maybe a trend is starting to emerge here. Let's keep going. 7,000 comma 4,000. Another 7,000 comma 4,000. Let's put that right next to it. 8,000 comma 3,000. Right there. 9,000 comma 100 and 9,000. Or 9,000, 1,000, 9,000, 2,000. All right, so we've plotted all of our points. If I tried to pass a line through this that has approximately equal number of dots above and below the line, it would go right through like there. In this line, all of these data points are pretty darn close to that line. This line has a negative slope, so we're going to say it has a strong negative correlation. All right, let's try one more. Practice plotting points. So I got to plot 2 comma 17, but I don't see a 2 down here. So I just got to approximate it. It's 2/5 of a box. So 2 comma 17, 19 comma 25, 19 comma 27, 22 comma 33, 25, 25, 27, 32, 56, so all the way over here, comma 51, all the way up here, 58, so just a little bit further over, 49, right up there, 60, comma 48, and 66, comma 59, and that's just a little bit off our graph, but that's okay, we can still see it. This looks like, if I was to pass a line through this, I could get pretty close to all of my data points. I would call this either strong or moderate positive, but since moderate isn't one of our choices, we'll just say strong positive. Actually, this just says whether it's positive, negative, or no correlation. We're adding in that word strong or weak to describe the correlation even better. Okay, so that's that for scatter plots. Now, be aware that the mastery quiz for level 7 is comprehensive of everything we've been talking about with Statistics Bootcamp, so be prepared for that. All right, have a good rest of your day.